I, Ganesh Varan, as a presenter today. Today's breaking news. A fuse box is overflowed by lightning electric charge, causing an entire house to be burned down in Jalan Genting Kelang, Setapak. There's a case of a death of 5 people recorded yesterday. So this fire was taking place from 8:30 and managed to be put down at 12 midnight. Recently, this has been a major problem in our country, Malaysia. So today we will have a very special guest from who is a senior engineer from the Ministry of Environmental and Science from the government side. So, Mr. Shah, we would like to know about what the government are looking for.
Well, due to this being a hot issue now, the government has actually come up with a plan to urge engineers around Malaysia to come up with a design of a fuse box that could actually prevent this from happening again. The government has also stated that whoever they can come up with this design will be awarded 500,000 ringgit in cash and a 5-year contract to actually build and maintain this fuse box.
Wow, that's great, isn't it? Okay, correct me if I'm wrong. From what I understand about fuse box nowadays, once the lightning strikes the home, and if there will be an overflow of charge which causes the circuit to cancel off. So sometimes the circuit might actually, the charge might actually not be cancelled off, striking the fuse box and might damage the home appliances. In some cases, it might also burn down the house. So I would like to know about the design nowadays that you are looking for.
Alright, so basically, what the government authorities are looking for is a fuse box specially designed to detect the negative charge from the lightning before it actually strikes the house. This is of course to cut the flow of current. The charge that are absorbed by the copper wire will have to be channeled to the ground safely. With this type of design, the house appliances and of course mainly family, the people living in it, can be safe.
That's good news.
Going to be a millionaire project. We're going to get a 500k. Are we doing it?
Yes.
Yes.
We are doing that.
We can do it, man.
Yes.
Welcome, Professor Shiva and Professor Aguilar. Have a seat, sir. Hi. Have a seat, sir. Alright, sir. So what are we going to discuss with? Hi, sir. I have found out this transistor MPF102, which is the function is to detect the negative charge. Can I? Yeah. Okay, sir. Now, I would like to tell you the diagram of this my pen. Yes, sir. Let me explain to you. Our power supply will be here, and it will go to a resistor so that it will reduce the current, so it will go to the MPF102 transistor. The function of this transistor to detect the negative charge. Once it detects the negative charge from the third panel, it will cut off the power supply, so that there will be no current supply to the house application over here. This will be, we will connect it parallel to the house circuit. So this is the idea roughly I will come up with. So do you have any questions, sir?
Professor, you say the current will cut off the MPS transistor, but then there's no switch or anything over there. So how can you just cut it off just there?
Oh yeah, you have a good explanation. Actually, we can add a switch over here. Yeah, that's a good idea. So how about you, Professor Aguilar and Shua? You want to add on anything?
Okay, right. For a resistor, right? It's actually a simple series resistor. So instead of using a series resistor inside a normal house appliance, we can use a parallel circuit, or we can use a bridge network. Okay, my idea would be something like this, where we cut off this resistor. Instead of the resistor, we use a bridge network. Okay, well. The function of the bridge level is actually so that it can reduce the voltage according to the supply. Because our supply is going to the house applicants. So for our house applicants, the supply from the generator is 240 watts. We need to minimize and reduce it to smaller wattage so that it can be capable or applicable to all the normal house applicants. So by using a bridge level, we can actually produce a better product.
Actually, Professor, actually, better idea. So it's a very good idea, but there's a big amendment that will be done in the circuit. So actually, my idea is, since you have a transistor, function is actually to detect negative charge. Okay, once the lightning hit the house circuit, what happens is the whole circuit is cut off. Once cut off, we don't have actually extra charge storage to actually lighten up the whole house. So what we need is an extra capacitor and a LDR, light dependent resistor. Why is this so? Because if you have this capacitor, its function is actually to store the charge, extra charge service. So once this current is, current is cut off, what happens is we have a capacitor to actually supply charge the whole circuit, and we have this light dependent resistor. The function of this light dependent resistor is actually to once the current is cut off, this light dependent resistor automatically will lighten up the whole housing applicants, because we have extra capacitor that store the charge inside the circuit. So I think it would be very appropriate if you actually adding this capacitor and this LDR to make the whole circuit looks perfect. So what you guys think about this?
It sounds so good actually. It sounds we made a perfect circuit so far. So
it's actually a good idea, Professor, because by adding a capacitor and an LDR over there, it's actually a brilliant idea where we can, after the power supply cut off, we actually reuse the current, or we reuse the current to enhance the light to light on. So we think the capacitor works really a good job. I think your audience is really great.
Because as you all know, most of the Malaysian applicants it's all like this, because
recently there are so many houses that are cutting out the power because of the lightning, right?
but actually it's better actually apply this both, capacitor and this LDR.
This technology can improve the real
whole circuit actually.
It's awesome, man.
So I think we shall carry on this project.
We should. Because the deadline is coming very soon.
Yeah, I think we shall.
so we should move on right now with Professor Shiva and Glenn.
Sure. We should work on it now.
We should go to the lab.
Alright, let's go for the lab.
玉たまま一度ついておいで世界中魅了するほどに豪華なジャパン一番ジャンプアランさうちらの出番テリヤキボーイズ in the place to be 見せてやろうオリジナル VIP
Many many diamonds dangling Bag full of money we strangling Hate me, fry me, bake me, try me All the above cause you can't get in I don't want no problem Big because me professional. Make you shake your cats up, thank you. Haters take it personal.
Like a Canada type, that's all now talk. Oh, let's go, not my money, let's all hot such kitchen, my also let's go, let's go. To heal level up, level color S go. Need you walk go, tonight need go, new work, so it's a show pain point.
I wonder if you know that it be Tokyo. If you seen it, then you mean it, then you know you have to go.
Hi, what else teriyaki, boys?
Hate me, fry me, bake me, try me, all the above cause you can't get in. I don't want no problem, because me professional. Make you shake your cats up, thank you. Haters take it personal.
Like a Canada type, that's all now talk. Oh, let's go, not my money, let's all hot such kitchen, my also let's go, let's go. To heal level up, level color S go. Need you walk go, tonight need go, new work, so it's a show pain point.
I wonder if you know that it be Tokyo. If you seen it, then you mean it, then you know you have to go.
Hi, 私照り焼きボイスあっという間吹き飛ばすノイズ慢心してますんでゲットペンの数も増えてますベーシックはサプライズでマジ毎日が危ないぜ忍者風賢者風だけどゲイシャーフェイクの惑星からのシャー
See me in the parking lot 7-Eleven is the spot Bikes with wings and shiny things and lions, tigers, bears, oh my ride We fierce and fast, supersonic like JJ Fatten We rock till the wheels are flat Can't beat that with a baseball bat
Like a cool on cueが遠さまでもいいぜ即歳よインターセプターしてこ
Welcome to Monday Morning News. Finally, after 30 long days, we have good news to all Malaysian citizens. We have found our great inventor for the fuse box design. And out of more than 100 fuse box design, we have actually chosen the best one. And it is actually called the Ultra Sensitive Lightning Detector. And guess what? They are part of our show tonight, so stay tuned to that. Now we welcome Mr. Shan from the Government Authority. And of course our Professor Ricky and Professor Agilan, who is the inventor of this fuse box. So now we will start with the question and answering session and I'll pass it to Mr. Shan.
We are fine. I have certain question to ask you. Why not we start with by explaining your design?
Oh, sure. Basically, this device is consistent of very little components, which is MPF 102 transistor, a resistor, and with a lightning, LDR, and this is capacitor. Okay, basically, the function of this transistor MPF 10 is to detect the negative charge. Once it detects the negative charge from lightning, it should straight cut the power supply to the whole house application so that it will prevent the power supply to strike the house application and damages could happen. So it is basically connected to parallel to the transistor. The power supply is connected parallel to the circuit to the MPF 102 and it is connected parallel to the transistor and LDR. That's how it works.
Fantastic, isn't it?
Great. I just have another question. Is it applicable to our Malaysian weather?
Okay, basically it's applicable in Malaysian weather since our weather doesn't fluctuate very much and it's very consistent throughout the year, whole year. So basically it should be very persistent.
I don't see storms or typhoons happening in Malaysia, so I don't see a problem.
So what are the advantages of using this design compared to our normal fuse box that we usually use?
Oh, okay. Normally the fuse we are using right now, it will work based on once the lightning strike the house and once once it's overflow in the circuit, thus it will close the circuit. But there is a chances to current to overflow in the fuse box and damages the whole house application. But in our product, it's not like that. It's basically once the device over here, the antenna from the transistor, once it detects the negative charge itself, it will close the power circuit. So once it's closed, the lightning strike or anything is happened to these house applications, nothing will be damages to the circuit, to the house application and everything. So I think that this device is much more safer than the fuse we are using right now.
So are you confident that you'll prevent houses from burning down like the previous cases we've had?
Oh yeah, I'm very sure with that. And this is just a prototype, and we are going to come out with a lot of major prototype in Malaysia soon.
Of course, the citizens of Malaysia would like to know how about the costs of this fuse box. Will it be reasonable to everyone, or is it going to be really expensive?
Actually, the project will be very expensive, but still, this project still can carry on because we are targeting on a well-developed area. Some maybe you can name it like places like KL. So around there we target only on well-developed area.
So are you saying that people from rural areas should just go and die?
Not to say like that, but we come up with a project a bit cheaper. We try to minimize the cost of the project.
I think we should look at the government side. They should have some subsidy for the people from the rural area.
Yeah, we definitely will provide something for people who are, less financially good.
So, is there any more question and answering session?
I'm pretty much done actually. I'm really happy to see a design like that.
Thanks.
Well, I guess there's still hope in Malaysia right now due to our great Professor Vicky and Professor Agilan. Of course, there's another professor who's also part of their designing and project for this fuse box invention. He's not here today, he's on holiday, and he's of course Professor Siva. So I guess we'll wrap it up here today, and we will of course present the prize to the winner. Now we welcome Mr. Shan to give away the reward to our two great professors. And also welcoming Mr. Vicky and Professor Agilan to receive the award. Yeah, it's been a great day. Malaysia, let's hope finally, I believe that. Thank you very much.